Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Meredith Chaiken, University of Albany, and Joel Chaiken. We are here, we are brothers. We are here to show you how to approach SAT math questions. Here's an SAT math question from a non-calculator section, and you can see what it is. You may want to pause it and come back. This is having to do with complex numbers. I think you usually do this somewhere in normal 11th grade math, which some kids take in 10th grade. And you're expected to know something about complex numbers. Even if you don't know something about complex numbers, they give you the definition of what I is. But if you've never seen this type of stuff in your life, you probably are not going to be in a position to do this. They're basically asking, how do you rationalize this expression? Rationalizing means that you want to get the right, you want to change this so that the denominator are only real numbers, no i's in the denominator. So that's sort of the trick here. Most people would realize that. No, it's horrible spelling of denominator. No i's in the denominator. So you have to rationalize this thing in the traditional, like run-of-the-mill, plain vanilla way to rationalize it is to multiply top and bottom by the conjugate. The reason why I'm pausing is because my Zeiss word frozen, but it'll come back in about a second. Here we go. To rationalize the denominator, you do 8 minus I, and you write this very carefully because you can really make mistakes here. And you multiply by this 3 plus 2I and 3 plus 2I. You're essentially multiplying by 1 because you're multiplying top and bottom by the same thing. And then you have to be really careful here. This requires you to really pay attention to what's going on. Now, wait a second, though. They just want you to know the answer. They just want the real part of the answer. One thing about this is every single number in the world, you could correct me philosophically, every single number in the world can be written as a real and complex. Every single number in the world has a real and complex part. The A plus BI. A is the real part, B is the complex part. Up until around 11th grade math, B has always been 0 before 11th grade math. So it's always been real number. But in general, every number can be written as a real and complex number part. And then you just have to FOIL this thing out to get the answer. This is a pain. The denominator, though, cancels out. You'll see if we FOIL it out, it's 9 and then plus 6I minus 6I. And then this is a minus 4I squared. But the square root of I is negative 1. So I squared is negative 1. So this is actually a 4. So this is a 4, which means a 13. I don't see a 13 here in the denominator. Okay. And now we only care about the real part. Well, the real part is 9 times 3, which is 24. And then this I thing, see 8 times 2I and 3 times negative I is going to relate to the b. So we don't have to even waste our time calculating that. And now this is, you have to be careful again. It's 2 times I squared with a negative sign in front. See? So this is negative 2 times negative 1, which is a 2. That's a 2. Let's see if this works out. 26 over 13. It does. Looks like the answer is 2. So you just got to be really careful. This is not a problem to rush on. You really got to watch and be really slow in doing your multiplications here because it's too easy to make a mistake. It really is. Because you have all these negative signs flying all over the place, and the I squared makes a negative sign. We didn't check the distractors, but something tells me that the distractors are there if you make some negative sign mistakes. So, yeah. I don't know. This is a plain vanilla way to do it. There's really no, I don't know. There's probably some super clever way to see it faster, but you know what you do when you just sort of plow through it. Seth's writing something.
Yeah.
So we have to move a little bit.
When you put a complex number into standard form, when you, as Joel said, FOIL out the denominator. Well, when you pick the multiplier to be what's called the conjugate divided by the conjugate, the product of the two denominators is always going to be the square of the real component, in this case is 3, plus the square of the imaginary component, which in this case is 2. So it's always going to be in this form.
Right.
However, to get the real part and the imaginary part that go into the numerator, you do have to FOIL it out. Yes.
Yeah. Yeah.
Now, Joel's point is that the question asks only for the real part, and so you need work out of the 4 terms from FOILing. You need only calculate 2 of them. The one where the real part of the first factor is multiplied by the imaginary part of the second, and the imaginary part of the first is multiplied by the real part of the second. So you got 8 times 2 plus
8 times 3.
The 2y up there is.
You're talking about the complex parts.
Yeah.
Okay.
No, to get sorry. Oh, yeah. No, they asked for the real part. Okay. So to get the real part, you only need to multiply 8 by 3, the product of the real parts. Oh, and then take the product of the imaginary parts, but you have to change the sign because the 2 imaginary parts both are products of I. And the 2 i's squared together, they multiply together, you get -1.
Right.
So you have -1 for the real contribution from the product of the imaginary parts. You take -1, the coefficient of I here, plus 2, the coefficient of I here. -1 times 2 is -2, but then you change the sign of it to account for the I squared.
Right.
So you get 8, you get 2. So the product of the real parts is 24, and the product of the imaginary parts, including the i's, is +2. So that's how you get it.
Yeah, that's how you get it, right.
Yeah.
So there's nothing much here to do. You just have to basically know that to take a complex number and turn it into this type of form, you have to multiply the numerator and the denominator by the conjugate of this number. The conjugate of that number, which is just 3, which is just the same number, but you change the sign. So that
of the imaginary part.
Of the imaginary part. So it's sort of like
the formula for the conjugate. In general, every complex number has the form A plus B times I, where A and B are real.
Yeah, right.
A and B are real.
Yep.
The conjugate of that is the same real part with the imaginary part changed in sign. So if the number is given A plus BI, the conjugate is A minus BI.
Right. And that way, when they FOIL out, the middle terms cancel. It's almost like a difference of 2 perfect squares thing, where you do x plus 7 and x minus 7. That's equal to x squared minus 49. It's similar, and that's the middle terms cancel.
So what Joel's saying is that the a complex number times its conjugate is always the sum of the squares of the 2 real parts.
Yeah.
Now, you'll recognize this as something that comes from the Pythagorean theorem. You have A and B. The square root in lengths of the sides of a right triangle. Hypotenuse is the square root of A squared plus B squared. Yeah. So they sometimes they'll sometimes say that the complex number times its conjugate is the square of the magnitude
Right.
of the complex number. So a squared, the square root of a squared plus b squared is called the magnitude or the norm of the complex number.
Right. Okay.
Okay.
Okay. Sounds good.
Mm.
Okay, everyone. Then please give us your comments and email us your SAT math question if you have one. And I guess that's it for today. Have a great day then, everyone. Take care. Bye-bye.
Bye bye.
Bye.